Equations in quadratic form. Quadratic form. Okay, well, quadratic form is this. Quadratic form is this, and you're really familiar with it by now. So we have ax squared plus bx plus c equals 0. This is quadratic form, where I have a squared term to the first power, and then I have a constant. So we're going to make them look like this, but to start out, they don't look like it. So we're going to take something that doesn't look anything like this, and we're going to turn it into something that looks like this. Okay, so here's an example. So our goal is this, because then I can factor it, because I have all kinds of different ways now that I can factor, right? I have you know, you can just try to factor it. Maybe it'll factor nice for you, or you could use completing the square, or you can use quadratic formula, you know, all kinds of ways to solve these things. But the equations that we're talking about are kind of scary looking. So we want to change from scary to something that's not so scary, okay? This I can't solve. I don't have the tools to solve that. But I could solve something that looks like this, I'm thinking. I can factor that. That's fine. This? No. That? Yes. Okay. So this I can't solve. Right? This I can solve. VE. Because I can factor it. So I'm going to go from something I can't solve to something I can solve. All right, well, if you look at these, you can see the difference. Here I have an x, here I have a z squared. Here I have a 5 square root x, and here I have a z. Well, what we're going to do, and on these you always kind of do the same thing, is you're going to look at, and I usually look at the middle term, because the middle term kind of tells you what's going to go on here. So if I look at this, it looks to me like this term right here is what I kind of dealt with. And I said, you know what? Z equals square root x. Do you see that? Z equals square root x, because I substituted it. I said, you know what? Instead of square root x, which is a little scary to me, I'm going to go ahead and put in z. Well, it follows that z squared equals x, right? If I square this, I square this. Once I square this, I get x. Well, so I use this piece, where am I? From here, right? And I put in z, and then I took this right here, and I put in z squared. So I put in z squared here, and I put in z here. And I just did simple substitution. Okay, the hardest part of these problems, of course, is figuring out what the heck z should be. And I have a little bit of experience looking for z, and I'm going to share some of that experience with you. And then you're just going to have to try some on your own, and that's how you'll end up really kind of seeing the light. So your first step is let z equal something. And you want to kind of look at the middle term. Look at the middle term for a clue. Okay, so usually that's what I do. I look at the middle term for a clue, and that I can actually see it once I look at the middle term. The second thing you're going to do, so step 2, which I've already done here, is you're going to replace with z. So you're substituting in z. Well, z allows us to actually solve the equation. So what I'm going to do here is I'm going to take this and I can factor that. That's going to be, that's easy. I can do this easily, right? Because I know how to factor. Two numbers, when I multiply them together, I get 6, and they're both going to either be positive or negative. And when I add them together, I get a negative 5. All right, well, I think that only leaves a negative 2 and a negative 3. Multiply them together, I get a positive 6. Add them together, I get a negative 5. So either z equals 2 or z equals 3. Okay, so our third step is to factor. Our fourth step is solve for z. Okay, well, once you solve for z, you're not done, because you really just found z, and they wanted you to find x. So you're going to have to go back and solve for x, or whatever variable they gave you. This, in this case, I have x. So what you're going to have to do is this. You're going to have to go, you know what? Here I have, and I have it in green. Let's see. Here I have the fact that z equals square root x, right? And I'm going to use it on both of these, because I said z equals square root x. So now what I can do is I can put in my 2 for z, so I have 2 equals square root x. Well, to solve this, I'm going to have to square both sides. So I'm going to go ahead and square both sides. This is going to give me 4, and that gives me x. So x equals 4. X doesn't equal 2. Z equals 2. X equals something completely different. So when you use substitution, you actually have to substitute back in so you can actually get the right number. And here I have 3 equals square root x, and I'm going to square both sides, and I have 9 equals x. Now, does it work? Well, I can take my 4 and put it back in here and check. I would have 4 minus 5 square root 4. Square root of 4 is 2. 2 times 5 is 10. So I'd have 4 minus 10 plus 6 equals 0. And yes, that does work. And I can put 9 in there. I can do the same thing, and yeah, it does work. So my answer for this one is 4 and 9. I found it using substitution with z. I always call them the z problems. Solve for z. And then your last step here is solve for the original variable. Okay, solve for the original variable. So this is an equation in quadratic form. We switched over to quadratic form so I can factor it, because I have so many tools to actually be able to solve a quadratic equation. And then I came back and I solved for my x. Okay, all right, here I'm down too low and I'm scooting this up so you can see. Okay. So there you go. Go ahead, pause the video, get the rest of those notes, and then I'm just going to show you a few more examples. I'm only going to show you 3 more examples, and one of them is a you-do. So this should be a pretty quick video. That won't work. Okay, so we have equations in quadratic form still. Make sure I've got my paper in the right place here. Okay, so here's another example. And these just kind of take practice, so I'm just going to show you examples, and the whole idea is getting used to what you can substitute in. So here's the next one. So I can't solve this, right? Can't solve. But I could solve something else. Now, the first one I just said, oh, but I can solve this. But let's think about this one for a minute. So this is my thought process here. I'm going to look at the middle term, and I'm going to say, you know, the 2 isn't, this 2 outside the radical sign is not ugly at all. I can handle that. But this 2 under the radical with the variable, that's ugly to me. That's something that bothers me. So I'm thinking this is what I'm going to look at. I'm thinking that that is what I'm going to set my z equal to. Because that bothers me. I don't know what to do with it. So I'm going to get rid of it. When I take z squared, so when I square this, I end up with 2x. And then I'm going to go and I'm going to look over here and say, oh, I am going to substitute then this whole thing with z squared. So my substitution then would be z squared, right, plus 2z minus 15 equals 0. So I can't solve that, but I can solve this. And so all I'm going to do is factor that. So factoring, I have z I have, let's see, 2 numbers, when I multiply them together, I get a negative 15. Add them together, I get 2. So 3 and 5. And they're going to have to be opposite signs. So I have a 3 and a 5. And I need my 5 to be the positive one because I have a positive 2. So when I multiply those together, I do get a negative 15. When I add them together, I do get a positive 2. So that's going to work. So either z equals 3 or z equals negative 5. Well, I solved for z, but I really need to solve for the variable, so I need to solve for x. Alright, so I'm going to bring down this green equation here, and I'm going to use z equals square root 2x for both of these. I'm going to substitute in my 3 for the z, because z equals 3, so I can put a 3 here. So I'll have 3 equals square root 2x. I'm going to square both sides. That's going to give me 9 on this side. And over here, I have the square root of 2x squared, so you guys know, and you've done these quite often, that you're going to end up with 2x. I'm going to divide both sides by 2, and I have 9 halves equals x. So that's one of them. The other one, I'm going to substitute in negative 5. And so I have negative 5 equals square root 2x. Well, my problem is that when I have a square root of something, I can't get a negative value. That's not possible, right? Because you'd have to, I don't even know what you would have to have under here. So this one is not possible, and this one is a no solution. Okay, it's just not possible. Because I can't have a negative. When I have a square root, I can't get a negative. That would give me an imaginary, you know, if I had an imaginary number or something like that, but that's not the case. So I have a no solution here, and my actual answer to this and the root is just the 9 halves. That's the only one that works. Okay, so it's just substitution. That's the only thing that we're doing is substitution. All right, so that's your second example. So go ahead and pause that video and get the rest of those notes. And we're going to go to the third example. Okay, so continuing on with equations in quadratic form. Here's another example. So I'm just giving you some ideas on how to figure out what z is, because I know you probably understand the concept. The hard part is always figuring out z. So here's another one. Okay, and I'm trying to show you all the possibilities here. Sometimes it makes it a little easier. So here's another type. And this one, you know, well, first off, you need to get it with 0 on one side. So very first thing you want to do is get 0 on one side. Okay, so you kind of need to do that first. So I'm going to go ahead and add 5 to both sides so I can have this really ugly thing. 6 over u minus 17 over square root u plus 5 equals 0. And so, you know, it's scary. This is a scary thing. It's like, what do you do with it? But if you look at it, because you can't solve that, right? And you guys probably want to skip that one. It makes you sad. And you need to change it into something that's going to make you happy, that you can actually do. So I am looking at this thinking, you know what bothers me about it? It's not so much the 17. I can handle a 17. But what bothers me is this over square root u. So I'm looking at this, and it's in the denominator, right? So I'm thinking with z that I'm going to say z is 1 over square root u, which then would make z squared equal to 1 over u. And if you look over here, I have a u at the bottom. So when I substitute in, what I'm going to end up with is z squared, but I still have a 6, so there's a 6 in front of it. So 6z squared minus 17z plus 5 equals 0. Something I can actually solve. So I went from something that's really scary to me to something that I can solve. And for some of you, that one is still a little scary. But you need to solve this. 6 could either be 6 times 1 or 2 times 3, and 5 is 5 times 1. So I need some kind of combination here that's going to give me 17. I know they're both going to be negative because this is positive and this is negative. So I know that they're both going to be negative. So I'm just looking at this, and what I'm thinking is 5 times 3 is 15, 1 times 2 is 2, so that would give me 17. So I'm looking at that combination here. So when I factor, what I'm going to have then is a z, I'm going to have a 2z, right, and a 3z. And I want the 3 to be with the 5 when I multiply the middle terms. And I multiply these two together and then these two together. And then I want the 1 out here. Okay, you guys know how to factor. Minus minus equals 0. Okay, so that's what I'm thinking when I'm factoring. All right, and then from there you guys know how to solve. So I have 2z minus 5 equals 0. Or 2z equals, I'm going to scoot this up a touch, equals 5, or z equals 5 halves. That's one of them. Or, right, I have 3z minus 1 equals 0, or 3z equals 1, or z equals 1/3. So I have these two that I'm going to have to deal with. I'm going to grab this green equation that I have, and I have z equals 1 over square root u, and that's what I'm going to be using for both of these. So I just grabbed my green equation and brought it down here, and so I know z, now this is, kind of going to have to use your math skills here. With this type, what I would do is I probably would do I would cross multiply. I think that's going to be the easiest thing. So cross multiplying, let's see here, I'm trying to find a beautiful color. How about purple? Right, I'm going to cross multiply those, so that's going to give me 2, and then I'm going to cross multiply this, and that's going to give me equals 5 square root u. Okay, so that's my cross multiplication that I did. And then I can divide by 5, right? So I have 2/5 equals square root u. I'm just going to square both sides. And I have 4/25 equals u. Okay, so this one's a little more difficult. Let me scoot that up so you can actually see it. Alright, a little more difficult here. But you can do it. You can still do it. It's just you wouldn't, maybe you don't know how to do, or just wouldn't have thought to do that. So here I'm going to do it again with 1/3. I'm just going to cross multiply because I have 2 fractions. And I think that's probably a little bit easier for you guys. I may not have done it this way myself, but for you guys it's a good way to go. Alright, so when I cross multiply, that's what I get. And I'm going to square both sides. And I have 9 equals u. So I either have 4/25 or I have 9. Okay, which is my answer. And you can plug it back in and make sure you got it. Okay, it's always a good idea. Just plug it back into the original and you'll see that you have it. Okay, so as far as steps go, get 0 on one side and then you're just back to the original steps that we had in the beginning of our notes. Okay, so I get 0 to one side, and then you're let z equal something. Look at the middle term, replace with z, factor, solve for z, solve for the original variable, which is what we did. Okay, so these are our original, and I just want you to add these to that. Okay, you do, and you're done. Okay, so here's one for you to do. Alright, I'm going to give you, this is actually I put an example here, but it's a you do. Okay, here's an example, but it's really one for you to do. Okay, so don't wait for me. Here you go. I think you're going to be able to handle this one. Okay, I'm going to go back to something that's not quite so scary for you. I did the scary ones, and let's let you do one that's not so bad. Okay, so that's what you're going to be working on. Let me make sure the paper is not crazy. Okay, go ahead and pause the video and do that one. Let's see how you do. Okay, so for this one, I'm looking at the 5 doesn't scare me. This x plus 2 thing scares me. So I'm going to look at this, and I'm thinking that z equals x plus 2, which then means that z squared equals x plus 2 squared, which is, of course, this whole thing, right? Okay, so I'm going to, instead of this, I have z squared minus 5 times z minus 14 equals 0. So again, this one to me is kind of difficult and I can't solve it, but this one is definitely something that I can handle and I can solve. So I'm going to take that one and I'm going to factor, so I have z, And 14, signs are going to be opposite because that's a negative. So looking at 2 and 7, I think the difference of 2 and 7 is going to be 5. So 2, 7. The 7 is going to be negative because my 5 is negative, and this is going to be a positive. So I have z plus 2 equals 0, or I have z minus 7 equals 0. So I either have z equals negative 2, or I have z equals 7. At this point, I'm going to need to bring back in my green equation, which is z, and I'm going to use it for both of them. Okay, so just bringing back in my green equation, and I'm going to put in a negative 2, and then it's just super simple to solve this type. I know you can do it, subtract 2 from both sides. I have x equals negative 4. Okay, and which is fine. Negative 4 is fine in this case. It's only if you have a square root that you have to be super careful, but I don't have a square root right now. And then I have 7 equals x plus 2. I'm going to subtract 2 from both sides. That's a really bad 2. Here we go. 5 equals x. So there's my other answer, my other root. So I have negative 4, 5, and you can put them back into the original way up here, and make sure that they work and that you're going to get the right answer. So let's go ahead and just think about it for a minute. So I had negative 4 plus 2. That gives me a negative 2, but I'm going to square it, so it gives me 4, right? And here I have a negative 4 plus 2 is going to be a negative 2 times negative 5, so that's going to give me 10. So I have a 4 plus 10 minus 14. Yes, that works. Here I'm going to have a 5. That's going to be 7, or 49. And here I have 7 times 2, I'm sorry, 7 plus 2 is 9, so 40, and I have a negative 45. And when I add those together, did I just do that right? Now I'm confusing myself. Let me put that 5 in. Sometimes I can talk through them, and sometimes not so much. I am just like you guys. Let's make sure this one works. So that's 7 squared minus 5 times 7. Oh, that was my brain error there. So I have 49 minus 35 minus 14 equals 0. So minus 35 minus 14, that's going to give me a negative 49. A positive 49, negative 49 gets 0, and that one does work. So there's my check. All right, good job. I will see you in class.